All right, let's jump right in. We're going to step into the world of a junior programmer, a guy named Timothy who's just hit a really frustrating wall. You know the feeling. His awesome new app is suddenly way too slow, and he has no idea why.
And Timothy, well, he just nails the problem with this quote. His app, the match logger, is supposed to record chess games. But the moment two grandmasters start playing at the same time, the second match literally has to wait for the first one to finish. Everybody's just standing around, and his code is the bottleneck. It's that one slow cashier.
And this gets us right to the heart of the matter. See, the problem isn't just about speed. It's about a fundamental limit to how his program is working. It's running synchronously, one thing at a time. And to fix it, he's got to figure out how to make Python do two things at once. Luckily for Timothy, his senior colleague, Margaret, is there to help. And she explains that really, there aren't one, but two different worlds that code can live in. One he already knows, and one he's about to discover.
So Margaret just lays it out for him. On one side, you've got the synchronous world. That's where Timothy is, and probably where a lot of us started. It's safe, it's predictable, one task finishes, the next one begins, but it gets slow. Then, on the other side, you have the concurrent world, the many-at-once world. This is the art of doing a bunch of things at the same time. It's fast, it's powerful, but it comes with this really ominous warning. It invites the chaos of many.
And that right there, that's the central challenge. The second you go from one cashier to many, you introduce a whole new kind of complexity. Sure, you solved the problem of people waiting in line, but now you've got a new problem. How do you keep all those cashiers from tripping over each other?
To really show him what this chaos looks like, Margaret gives Timothy a perfect and, honestly, a very weird example of what can go wrong.
She introduces him to this absolutely critical idea, the race condition. This is like the classic bug of the concurrent world. It's what happens when your program's result basically becomes a lottery, and it all depends on which task happens to finish a millisecond before the other.
So, imagine you've got two tasks running. One is trying to write winner Timothy to a file. At the exact same microsecond, another task tries to write winner Margaret. Well, if they both try to write to the same spot at the same time, you don't get one or the other. You get this corrupted, nonsensical mess, Tim Margrethy. That, right there, is a race condition in action.
Okay, so now that we know the danger, how do we actually manage it? Timothy asks a great question. If concurrency is so much faster, why wouldn't I always use it? And the answer is complexity. But when you do need that speed, Python gives you a few different tools for the job. And the key thing to get here is there's no single best answer. You have to pick the right tool for the job. So if your code is spending most of its time just waiting for stuff, waiting to save a file or waiting for a response from a website, that's I/O bound, and threading is your friend. It's perfect because while one thread is waiting, another one can get some work done. Now, if you're doing a really intense math that's hammering the CPU, you need the raw horsepower of multiprocessing. It actually gets around some of Python's internal limits by firing up code on different processor cores. And then, if you're building something like a web server that has to juggle thousands of network connections at once, the modern way to do that is with asyncio. Picking the right tool is half the battle.
So to pull this all together, Margaret gives Timothy a kind of cheat sheet to help him start thinking concurrently. This is the mental model he needs to survive in that many-at-once world. First thing, she says, always remember your baseline. The synchronous, one-at-a-time world is where every programmer starts. It's simple, it's predictable, it's easy to figure out when something goes wrong. Its only real weakness is waiting. Second, you have to embrace the new way of thinking. The concurrent world is your goal when performance really matters. It's blazing fast, it's super efficient, but you're paying for that speed with complexity. You have to be deliberate and plan ahead to manage that chaos of many. Third, you have to be paranoid. You have to constantly be on the lookout for that Tim Margrethy bug. The rule is simple. Anytime you have multiple workers that might touch the same piece of data, you have to protect that data. If you don't, you're just asking for a race condition. And finally, Margaret drives home what is maybe the most important point of all. Concurrency is a trade-off. It's a powerful tool for sure, but it's not some magic wand you can wave to make all your code better. You should only use it when the performance boost you get is absolutely worth the headache of the extra complexity. Sometimes, you know what? The simple, synchronous way is still the right way. And this leaves us with Margaret's final thought for Timothy. He's learned why he needs to hire more cashiers, and he knows what tools to give them. But the next step of his journey, the very next puzzle he has to solve, is this. Now that everyone has a pen, how do you teach them all to share the same piece of paper?